Welcome to another MECH 1000 video. We are looking at Unit 9 in the Blueprint Reading textbook, and in this chapter we are going to look at threaded hole specifications. So threads are the grooves inside a hole that fasteners screw into. So screws and bolts fit into these holes. And so you can have internal threads inside a hole, and they correspond with the external threads on the fasteners themselves, those grooves that you see going around a screw or bolt. Those are what we call threads. And when we look at a blueprint, oftentimes in the hole note, you will see thread specifications, and it's a lot of alphanumeric information, and so we need to be able to unpack that information to determine what it means. For instance, here we have an example hole thread 0.250-20 UNC-2B. Now, if you don't know what any of that means, it just seems like a bunch of random letters and numbers. But there is a way to decode that, to understand what that all means, and that's what we're going to learn in this chapter. So the first number is always the diameter. That's always the most important piece of information in a hole or threaded hole or in the external threads of a fastener. So the first piece of information is the diameter. So this is telling us that the diameter of the hole is 1/4 of an inch, or 0.250. The second number indicates the number of threads per inch. So if we had a hole that was 1 inch deep, it would have 20 threads. UNC indicates the thread series. This is Unified National Course. It has a fit of 2B. And we'll look a little bit more closely at what all those things mean here. The first number, by the way, oftentimes is expressed as a decimal, like 0.250. That's 1/4 of an inch. But there are other ways of specifying hole size, including letters and numbers for some of those in-between sizes. And again, we'll look at that a little later on. So as I said, the second number in the series indicates the number of threads per inch. In this case, 20 means 20 threads per inch. So if you were to count each individual thread along a 1 inch length, you would find that there are 20 of them. The third set of numbers is the form and series. Unified National is the form. Course is the series. So Unified National is the standard types of threads that we typically use in the US. And you can have coarse, fine, or extra fine. Coarse is probably most common, but it sort of depends on the application. And then the last set of numbers, here we have 2B, indicates whether the threads are internal or external. So external threads would be like the threads on the outside of a bolt, whereas internal threads are inside a hole. And the 2 just before the B indicates the fit, the type of fit. Okay, so again here we are seeing that thread designation indicating that the major thread diameter is 1/4 of an inch, 20 threads per inch, unified form, course series. The class of fit is 2, and the B indicates that it's internal. And in addition, in this note, it also tells us the depth of the threads. The threads don't always go all the way down to the bottom of the hole. So the hole might be deeper than the threads. In fact, in reality, you need to have the hole be a little bit deeper than the threads, because the way that the threads are made is after the hole is drilled, the the threads are cut with a tap, and when those threads are cut, shavings may fall to the bottom of the hole, and so you need a little bit of area for those threads to go, and then you can back the tap out and remove those threads, but it helps to have a little bit of extra room at the bottom of that hole. So most holes are threaded right-handed. You may have heard the expression righty-tighty, lefty-loosey. So that just means that we turn things to the right or in a clockwise direction in order to tighten something or to advance a screw. But they can be threaded in the opposite direction. And if that's the case, then you'll see the abbreviation LH at the end of the thread designation. Here we can see a chart showing us the unified thread series. We have the first column of information is telling us the major thread diameter and what its decimal equivalent is. So as I was mentioning before, oftentimes you'll see the size of a hole in just a fraction or decimal, like a half inch. Half inch is 0.500, so you might just see 0.500. But you can also specify the size of a hole with a number, okay, like 0, 1, 2, 3, 4. And so you would have to refer to a chart like this. If you saw you had like a number 4 hole, for instance, that doesn't tell us what the dimension or the size of that hole is. You'd have to refer to the chart to see that that diameter of a number 4 hole is 0.112. So charts like this are necessary for knowing the exact size of some of these hole types or hole sizes that are designated with numbers. And also there are some designated with letters. On this chart, I'm just seeing the one letter jumping out to me here of Q. And so again, this what this letter is telling us is the tap drill size. So let me back up here for a second. So we have the major diameter and its corresponding decimal equivalent. Then we have the number of threads per inch, the TPI. And then the next columns here tell us the tap drill size. So you drill a hole that's a little bit smaller. So if we want to end up with a half-inch diameter hole, first we drill a hole that is only 0.422 inches in diameter. So we do that by using a 27/64 drill. Oh, and look, there's a couple other letters, F and U. So there are a couple scattered around here if you look for them. But so the size of the drill bit that you would use might be fractional size or designated with one of these letter designations. And so we drill a hole that's a little bit smaller than we want it to be after the threads are cut into it. So we start with a 0.422 diameter hole. We cut in the threads, and after those threads are cut, the size ends up being 0.5 when all is said and done. And again, in the unified series, we have coarse, fine, and extra fine. So you could have a half-inch hole that is coarse, that has 13 threads per inch, or you could have a half-inch hole that has fine threads, that's going to be 20 threads per inch, or you could have a half-inch hole that is extra fine, and so that would have 28 threads per inch. Here is a chart that shows all of those drill bit sizes that are designated with numbers or letters. So they go from 80 up to 1. So these drill bit sizes are meant to fill in the gaps in between the various fractional sizes and you can look them up on a chart like this. So if you see, that in a drawing that a hole requires a Q tap drill, you could look it up in this chart and see what that diameter is. That corresponds to 0.3320. Or like, for instance, if you go to the hardware store to buy bolts, like those ones that come in like little plastic baggies that you might get from the home improvement store, number 8 and 10 are very common sizes. 8, 10, and 12 you might see hanging on the shelf. And so those diameters of those bolts or screws correspond to sizes like 0.189, 0.193, and 0.199. And then it goes from, usually it goes from 12, 10, 8, and then, well, you might see 6 as well, and then it usually jumps up to 1/4 of an inch and goes on fractional inches from there on up. So again, here pointing out Q, this particular drawing indicates the tap drill size that is required. That's not always the case. That information is not always given. In fact, oftentimes you're just given the diameter of the major thread diameter, 0.375, and then you would have to look up using a chart like this. You'd have to be like, well, okay, 0.375, that's 3/8. Here we go, 3/8, or 0.375, 16 threads per inch. If I want to do coarse threads, I'm going to need a 5/16 of an inch tap drill. If we want to do fine threads, that's going to require a Q tap drill. And if we want to do extra fine threads, that's going to require a number 32 tap drill. So oftentimes this is the only information that's given on the drawing, and you have to look up using a table like this what the tap drill size would be. In this particular case, though, the tap drill size is given. You need a Q sized drill bit, and it even tells you in parentheses what that corresponding size is in decimal form. So we need a Q-sized drill bit in order to make our 3/8 of an inch, 24 threads per inch, Unified National Fine 3B. So this one's a class 3 fit, and it's left-handed. So that's a whole lot of information there, but we need to be able to interpret all that to figure out what all of that means. So I think this might be a good place to stop. Coming up, I just passed the 13-minute mark, so I'm down to just 2 minutes left in this video. So I'll just cut it off right there, and we will resume with the next video.